Now let's move toward custom Nuke gears. So just for previous recall, we have moved from HSV to hue gear, then saturation, as well as we have seen Nuke Chroma gear using gear node. So in this Chroma gear section, we have seen various Nuke nodes that are found inside Nuke, whereas we have used somewhat custom tools to call it as Chroma gear. And now in this lesson, we are doing something differently. In this session, we will make our own gear using mathematical expression workflow. We will call it as RGB gear or Nuke custom gear. That is the expression-based custom Chroma gear. So before starting, let's add some backdrop to call it as custom gears. So selecting here, adding backdrop, and now just moving this into side. I need to change this workplace to floating format. So going over here, split vertical, and then select it as Properties tab. And select to hide the tab. Alright. So this one is node graph. Also, let's close these properties to work it as full node graph workspace. Here, just name it as File Custom Chroma gear. Also set this font size to 30 and close it. Also little neutral gray color. Well, here is our sequence. And the same used in Nuke Chroma gear. Used for color correcting the sky area. So now let's just start to work on this sequence. But first, let's play the full frame sequence. Okay, so what we're doing is we're introducing and generating Nuke custom gears. Generate from inside the Nuke based on RGB values. For example, let's see. By sampling this area, this has some color values on it, and by calculating, it has the highest red value. This one has some RGB color. This have much green value. So using that, we can also key out this area, this tree. Also this one, the area where it has green values the most. So without further discussing, let's just do it in practical. Alright. So first of all, before adding any of the node to work, let's start process with Denoise tool. Because before working on any of the key extraction, we need to add denoise for reducing or removing noise from plate to get our matte clean. So for that, let's first add denoise. But before moving to place our analysis box over even area, just come here for change it to film. And now, same as previously, let's place over a neutral gray area as possible. And sometimes I prefer to work in this floating format because this is the way I prefer to work. Okay, so here is input plate and this is denoise plate. And while comparing, here we have removed grain for keying. So as we have a denoise node, in next we are going to add our first expression node, where we can add some equation to perform operations. So pressing tab and type expression. This node. And here it is. This is for adding expression. So let's move toward working on this. Here we have RGB tab, and this is active red, green and blue. and this is for alpha. So by adding expression, we can treat our individual channels here by specifically going toward our RGB and alpha. Well, for this sequence, we have to deal with alpha for further color correct this section. So the keyer means extracting our matte, and in this session, we are extracting alpha based on expression node. We are adding certain expression or mathematical operation, and then we will use them further with expression node. Now let's start working toward expression node for extracting the key. So open up our expression node for working. Looking at red, green, blue, and alpha, and we will work on this alpha in this RGBA.alpha output. Here is only blue active, green active, and red active. Let's come here in alpha channel. Right here, we are adding some expression, and please note this expression while I'm typing. So let's start adding those. So we are typing SQRT, which is square root, open parentheses, POW for power, again open parentheses, then typing red channel. For that, typing small r, then minus. And what are these for? We will discuss shortly. But first, let's note it down while I'm working. Now typing capital R, comma 2, close parentheses, plus POW, open parentheses, small g means green, minus capital G, comma 2, close parentheses, plus POW, open parentheses, small b for blue minus, capital B, comma 2, close parentheses, and close final parentheses. So we are putting this expression in alpha channel, and here this kind of expression looks complex for me too. So this is actually a Pythagorean theorem for 3D coordinate system, and I found this expression while working on Jungle Book movie from one of my supervisor. So this is some sort of 3D keyer which calculate key based on distance between RGB and the screen we are sampling from. So looking at this expression, we can see familiar phase such as small r and capital R. So small RGB indicate red, green, and blue channel, and capital R is secondary red, green, and blue. And these need to define differently. So in Nuke doesn't understand this capital R, which is secondary. Nuke can understand this is red, this is green, and this is blue channel. In Nuke, that capital values are needed to define separately. And we can tell Nuke that these are the secondary screen color values we are going to take sample from. These are temporary channels, such as red, green, and blue, and this is alpha. And we need to tell Nuke that what this value represent for. So capital R means we are placing this in red channel, capital G in green channel, and capital B in blue channel. Also, we can actually replace capital RGB into another name. Such as A for red, B for green, and C for blue channel. And we need to tell them like A for red channel, B for green channel, and C for blue channel. Sorry, B and C. B and C. So by doing this, what is going to happen on alpha channel? Let's check. So looking at this, it creates alpha channel based on the expression we have created. Before, we didn't have any alpha. Check on that. And now going to expression node and alpha channel. Here we can see alpha generated using this Pythagorean theorem. So if we add another value such as G, it is showing differently. In here, let's add 0, 0, and 0 in all. So now here total black. And because of this, we need to define the values to take sample from the screen. Now reset the values by putting back capital R. This is capital G and this is capital B. Again, we have to set in here. So capital R, capital G and capital B. And now we get alpha channel, or sometimes it is also referred as grayscale image. So looking at this grayscale image, for instance, as we adjust viewers gain and gamma, we can see some black and white difference. As to confirm, we can extract key from this. But now, this is advanced reason for creating this expression-based chroma key. What is the advanced reason? So the answer is, from the expression node, we can create some sort of 3D key. So it will create matte based on sample values. For example, if we select this, it can create matte on this region based on the distance between RGB color values. Also on this tree section, it can generate matte based on channel. For that, we need to create certain tabs. So from there, we can sample our screen and extract the matte from it. So let's go into our creating properties tab. And for that, right click and selecting manage user knob. So in here, selecting add, and what we're doing is we're adding RGB color knobs. Here we can see RGB color knob and also in here RGBA color knob. So since we are taking sample from RGB image, not from alpha, this pipe is directly connected to denoise to input plate, because from this keyer we will output our alpha for further performing the color correction. And that's why again right click and going over manage user knobs. Then selecting RGB color knobs. Now we got two fields such as name and label. So for the label section, we are going to put name on it. And name should be unique and in small letters. So writing small RGB and without adding any space. Type key. So this is RGB key. And in label section, I'm going to write capital RGB. And then key. Okay. So here we get tab as RGB key. Press OK. Here is individual sample channel such as red, green and blue, used for sampling the color values to extract matte based on their color information. And then this is sample field. By sampling, I can select area on screen and extract the key. Also in here, we can rename this username field here. So just rename it as same RGB key. So I can right click, manage user knobs. Here, we can see user. Now going to edit. So since here is user and label, on name, we are keeping this name field as it is and changing the label field and rename it as RGB key. Now user and RGB key, press OK. Done. And we can see the same RGB key and RGB key. And going on here, by looking through expression node, open up node, we get sampler and color knobs. So we can take sample, but before that, we already have alpha channel. And that's because of this expression. So most importantly, we have defined RGB values in it for sampling the color. So going over screen, pressing Ctrl and click. And now on this, we can see that the values are changing in RGB. But we didn't get any matte based on sample region. That we can use it as key. So for example, let's selecting this region. But the matte remains unchanged for this region. Seems like no effect at all. The values are calculating, but we didn't get any matte. So what is the issue? And this is because we actually didn't tell in this expression node that these sampler values are needed to be connected with this expression. And currently, whatever we sample, they are not connected with this expression. So we have the sampling values, but we're still unable to see an output. Well, we need this value to be directly connected with individual RGB field. And for that, let's go into our RGB key field and place the cursor toward these tab properties. We can see the yellow line strip indicating RGB key in small letter. So we need to connect this RGB key onto this region, and it specifically indicates that this one is connected with red, this one to green, and this one to blue. This is RGB key, and this key needs to be connected with expression, which specifies the sampling value. So writing RGB key, and then this is red channel, we are connecting straight. So R, here it is RGB key dot red. On another, RGB key dot G, RGB key dot green. Now check that. Now the alpha is calculating. So on final, RGB key, and last final values, that is B. So here we have normalized the matte. And now by going on this RGB key tab and select. So whatever we sample, this is going to update. We are seeing in real time. On this plate, I'm finding the best place where I can sample out the values from. Okay, so now on this region, press Ctrl Alt and select. So in this region, we have taken the samples. But this is black, and we like to work in white matte output. So add invert. Now we can see we have our matte which have inverted. Okay, so we can also refine this by going to the node, and based on this value we can find better spot from sampling the values. Again, on this region we can extract matte on those specific section, or for instance this tree region have some core green color, and as we sample we get this specific region matte. So the other part which have core green color are also going to cover, and sampling core color can get us best possible core matte to work. And like previous Nuke Chroma here, it works best when they are having core RGB color on plate. Evaluating our initial matte by hovering toward gain and gamma is very necessary. This defines how our matte going to look for. Next, we are adding grade node after invert to remove this excessive noise area or sky region. So for removing noise, let's first change channels to alpha. Now adjusting black point, so we could get rid of noise that are on black region. Black point helps to remove unwanted noise region to make a matte clean, but don't do in extent. Okay, nice. And in this white value, let's reduce the values a little. At this one, it pushes the pixel toward white. And we don't have to make it core white and sharp. Leave it as enough. This matte is not very clean or base key, which is normally used for garbage matting purpose. For instance, let's see if we can key out from this region to use for color correction. Let's take another region with possible core RGB color. This can give us even better result. So let's try to key out at this part. Already we have done keying, but again sample this out. Pressing Ctrl plus Alt. Okay, this is the key. Now going invert, and here by tweaking where this part is also covered. This is actually a bird matte, and it also have cover during extraction. Here we get our matte. So based on sampling the same color, we can get core uniform matte. which works same like previous Nuke Chroma keyer. Check this region again. We have the same green color as this, and finally getting same uniform matte on these. Now we can also clean up the matte chunk by adding roto shape around the noise area. So let's adding roto by pressing O hotkey, selecting Bezier, go to large frame. Now let's start drawing the shape. And pressing Z for soften up. Now let's animate the shape, and here no need to be perfect, just going over 10 to 20 frames. So one important note that we can of course remove this noise from grade node using black point without applying any roto. But doing this overall can create our matte sharp, whereas doing with roto can output no noise and where edge will be clean and soft. That's why we have used roto to only adjust where the noise levels are large. Now checking the shape amongst various frames. So here whole complete area is covered. Now we can add grade node and then connect mask to our roto shape. Then selecting channels to alpha. And now using black point, so we can clean out the unnecessary matte chunk. Also we can tweak white point to increase the opacity on matte. And just little adjusting in black point. So here we go. For this session, instead of using grade node, I'm looking forward to work in color lookup node. So let's add in color lookup. This is classic alpha and color grading node with their curves to handle black and white point more precisely. Alright. Now connecting to input plate, and the same as grade node, let's connect our mask to roto node. Now here is also the channel set to RGBA. So it will affect RGB and alpha. And this is the master. So master is the combination of RGB and alpha channel. And this is individual red, green, blue and alpha channel, responsible for treatment on color and matte channel. Here we have slope or curve. This point is 0. Here we can note that this is 0 value. And this is 1. Now adjusting this value one side, so look on that. We are affecting on white matte region, its opacity. And on the 0 side, we can adjust in black region. Now select point and delete. And if we add a point in middle by pressing Ctrl, Alt and click, so we can have a point that we can adjust from middle. This middle point is gamma. We have seen in grade node, which affect in between the black and white values. And it is not true that gamma doesn't affect constant 0 and constant 1 value. Sometimes working on CG for adjusting in black levels, we use pure black point to only affect perfect black and perfect white, but it actually does not. So let's compare with grade node. Here this is gamma up above, this is black point means 0, white point means 1. And of course gamma affect in between 1 and 0. But some people say that adjusting gamma doesn't affect pure 0 and pure 1 value. But I can show you how it can affect our values. So let's see this in full screen by pressing spacebar and reset our setting. Press F to view on frame. Looking at this, so this is 0 and this is 1. And the gamma means affecting the values in between 1 and 0. For that, I have added point in between. So if we adjust gamma or midpoint, see the curve on black point and white point? They are now moving. So have closer look at both point, how their curve changing its position. Here, one thing we might do is adding some point near the black point as well as near white point. So here selecting point and right click and select linear. Also the same on this point, select it linear and then adding midpoint. Now as we are moving, we are only moving our gamma point. But note that this is not curved gamma point. This looks like two lines intersecting with each other. In gamma, we want curve with softness on matte. Let's just change it to now something like smooth. In here, we are now only affecting in between values without disturbing black and white point. And if we want to move this handle freely, so hold Control and now we can move this freely. And in here, see on those noise? We can directly control the noise from adjusting the handles. And due to adding point near black point, we're unable to completely remove the noise. And this is because of this point. So let's remove this point. Now, see that we can adjust more in non-linear way. Now, moving on. And let's pushing this curve towards 0 to clear noise pixel. And tweaking this to push the opaque white pixel toward 1. Adding point so to remove that remaining noise or black region. Press F to view this curve on full screen. And this way we can add individual point to work on specific region or part, as opposed to work universally using grade node. And by using it, this color lookup node gives more control, and using this control point really helps to retain and maintain soft edges wherever we need. So this is all about color lookup node, and during classic compositing and up to now, many artists prefer this curve based node. But on the other hand, using grade node makes no much difference, and after all, this is all about our alpha. Here I think we have small noise region that needs to remove. So I'll open up color lookup node, selecting alpha, and let's push this curve a little. Alright. And here we go. Alright. Now the final step is adding crop node and doing reformat. Now this is alpha output, and for the final step we are looking at this original input grain footage. In here we have our grain, and this section is our key part. So view our original plate. Let's add grade node for color correction. Connecting our mask input to the matte. This is our mask or matte. Now let's move into color correction using mask. So going in gain, adding some cool tint, and check that in. The color correction only affecting the matte region. Now adding little blue in it, maybe increase red and blue. Here we want little cool color effect. So now let's compare with original input plate. Here some blue cool effect on it. This is not looking evenly flat because our keyers generated alpha matte with having some variation on transparency. Here this region has matte holes in it due to the rotospline misplacement. So no color effect on this region. This region is having some black sharp pixel here. We need to blur that sharp rotoshape. So we can add blur after rotoshape, just giving some large blur to blend with surrounding edges. And also in addition, using feathers to blur the edges. So as we are having keyframe set, now going to ripple and let's add feather on it. so that our sharp edges does not look so obvious. And because it is set by using this ripple, this shape will automatically fix on complete frame range. Let's check this out. Due to ripple, shape have automatically fixed on complete frame range. And be sure to switch it off once it has no use. Earlier we have only removed that section and did these fixes in rough. Now let's just move toward comparing with output plate. For that, let's use wipe tool. So let's see that this color correction. And sometimes this expression based keyer helps to add diffuse color. As we are seeing in here, this blue color is nicely fit into this place, which feels like diffuse light source. Also looking over here, this blue tint is rightly added over green region, comparing with red, green and blue. Okay. So this way we have worked to our expression node and understood its working. And the final step is adding crop node and then reformat. So to force this into original format. Now, so this is all about creating chroma keyer using expression, which might be useful for extracting key. And to remember this equation, we can better write them using sticky notes. So press tab and type sticky note. On this, we can write this expression for further use. Let's write expression. So sqrt, open parentheses, POW, open parentheses, small r minus capital R, comma 2, close parentheses, plus. Now repeat the step again. POW, open parentheses, small g minus capital G, comma 2, and close parentheses. We have already done with red, so now using green. So small g minus capital G, comma 2, close parentheses. Now final step, so red, green, and now blue. Here adding plus, POW, open parentheses, small b minus capital B, comma 2, and then close final parentheses. And we have open parentheses, so close the expression using final close parentheses. I'm rechecking this expression with expression node. So let's check with expression node once again. Alright, fine. Now close it. Let's increase the size of sticky note. And placing this expression over the node tree. So in this way, we have come to finish our custom chroma keyer, as well as chroma keyer section. We have done with 3, 4, and this is 5. And here we have completed our session. So in final, let's play our sequence and come back after finished cache. Well, this is the finished composite. Let's see last. Before and this is after. Somewhat feels like cool diffuse color correction based on this matte we have generated. So this is all about custom chroma keyer using expression. And on next chapter, we will see another lesson. Till then, bye and see you in the next.